Well, there's more properties to parallelograms, and that's what we're going to dive into today. So one important property about parallelograms is that the opposite sides are also congruent. Opposite sides are parallel, and opposite sides are congruent to each other. So in the coordinate plane, we're just going to use the Pythagorean theorem to show that they are congruent or not. Opposite angles are congruent. We're not going to deal with that in the coordinate plane, but you'll see an example here, not in the coordinate plane, how we can use that to help us find a variable. And then the third important property is that diagonals bisect each other. And when diagonals bisect each other, or any lines bisect each other, they share the same midpoint. So when we deal with the coordinate plane, the two we are going to look at here are opposite sides are congruent and diagonals bisect each other. Those are the two we are going to primarily look at today. You can also use what we talked about on Friday, the opposite sides are parallel. So if we take a look at example 1, it says quadrilateral RSTU is graphed below. Determine if the quadrilateral is a parallelogram by showing that the opposite sides are congruent. Okay. There are other ways to show that that's a parallelogram, but you have to go based off of the directions they're asking you to do. So the directions they're asking you to do or show that opposite sides are congruent, so we have to show that opposite sides are congruent. You can't just make up your own method. Okay. Well, we just said when we want to show that sides are congruent, we are going to use the Pythagorean theorem. So pick a side, it doesn't matter. Which one do we want to start with? RS. So let's find the length of RS. And again, we're going to use Pythagorean theorem. So we're going to make our right triangle. The side you're trying to find is always your C. Doesn't matter, make that my A and that my B. And plug it in. When we count, what's the length of our A? 3. So it's 3 squared. What's the length of our B? 9. And what is 3 squared plus 9 squared? What is it? So 9 equals C squared. And then what do we have to do to both sides to get C by itself? Again, you don't have to simplify that. You don't need to plug it in your calculator. You can leave it in radical 90. That's totally fine. So now we have to show that the side opposite of RS is also radical 90. Well, what side is opposite of RS? TU. So let's find the distance of TU. So make your right triangle. Side you're trying your C, make that A, make that B. So lock it in. And what do we get when we count our A? 3. What do we get when we count our B? 9. What do you notice about the numbers from TU and RS? They're the same, so what's our answer going to be? What's the length of TU? Square root of 90. Don't really have to do any more work there. When that happens, that's totally fine to jump into, well, they have the same numbers I'm squaring, the answer is going to be the same. You don't have to re-go through and plug all that in your calculator and write it down. Okay. Yeah. So pick another side. We can keep going. If we did not get radical 90, then we could stop and say, no, that's not a parallelogram because opposite sides aren't the same. Okay, but we got that opposite sides were the same, so we're now going to check the other two sides. Which one do we want to check first? ST. A little cramped. S. Make your right triangle. C, we'll make that A, make that B. Plug it in. What's the length of our A? 5, so it'd be 5 squared. Plus, what's the length of our B? 3. And what is 5 squared plus 3 squared? 34. And then what do we have to do on both sides? So C is radical 4. So now we have to see the side across from that is also radical 54. What side is across from ST? Is it the same? Yeah, it should be. We go make our right triangle. That's our C. I'll make that A. When we count, our A is 3, so it's 3 squared. Our B is 5, 4 is 5 squared. We get the same numbers. Yes, they're different order, but they're the same number, so we know they're the same. We know R U is also radical 34 without having to do any more work. So is this a parallelogram? Yes, so your answer somewhere, well, you have room, you would say yes, and then you would just say opposite sides are correct. And again, your math is backing up that statement. So don't just look at it and be like, oh yeah, they look congruent. Yeah, opposite sides are congruent. You have to show that math to back that up. Right? So by finding the length of all 4 sides and showing me the length of all 4 sides, it's backing up this statement that yes, opposite sides are congruent. You have to show your argument and your answers. Questions? So now what we're going to do is we are going to show that the diagonals bisect each other. We know it's a parallelogram. We just proved that in the first half. But now we're going to show that the diagonals do bisect each other. And we said diagonals bisect each other. They have the same midpoint. So let's create our diagonals and find the midpoint of each diagonal. So a diagonal again is connecting opposite angles. So we're going to connect U with what angle? S. So we're going to go to U to S. So think back to Unit 3. When we find the midpoint, midpoint is where on the line segment? Middle, right? It's exactly halfway. Well, all you have to do, again, remember from Unit 3, count up and over. How far, to connect from the bottom of the diagonal to the top of the diagonal, how far up do we go? We went up 8. How far right did we go? 12. We went up 8 and right 12. Well, your midpoint, if it's halfway, is going to be half of that. So what's half of 8? 4. So we're going to go up 4. What's half of 12? 6. So we're going to go up 4, right 6. And there's our midpoint. What are the coordinates of that midpoint? 3, 2. Okay. So now let's find the midpoint of RT. And connect those opposite angles. We're going to connect R to T. And you can kind of tell, yeah, they probably have the same midpoint, but again, back it up. Do the math. Same thing. How far up do we go? 2. And then how far left do we go? 6. Cut those in half. So which direction are we going to go now to find the midpoint? Up 1, left 3. And do they share the same midpoint? Yeah, they both landed on 3, 2. So the diagonals bisect each other. Same midpoint. Therefore, they bisect each other. If you got 2 different midpoints, then they wouldn't bisect each other. But you should get the same midpoint because we already know it's parallelogram. Questions over it? With example 2, I cannot talk this morning. Parallelogram ABCD has coordinates of 7, 1, -2, -2, and 0, 3. What must be the coordinates of point D? Okay, so we're missing one of those coordinates. We need to find the other. So let's go ahead and plot these points. And order is really, really important on how you connect your points. Okay. This is A, label B, C. You have to connect your points in the order that they are written. So we are going to connect A to what point? Comes after A? B. So we're going to connect A to B. And then we're going to connect B to what point? C. Okay. And then C would connect to what? D, right? Well, think about what we know about parallelograms. What do we know about their sides? So two parallel sides, and we also know their sides are congruent. So we can use that information to help us figure out where D is. Because if opposite sides are parallel, then wherever D lands, CD has to have the exact same slope of BA. Opposite sides have the same slope. So if we can figure out what the slope of BA is, then we can figure out where D is going to land. Okay. How do we find slope again in the coordinate plane? Rise over run. Good. Okay. So we went down. How far down do we go? 3. We went down 3, so it's what? Negative. Right. And we went over. How far over did we go? 9, right? We went left 9. What's a negative over a negative? Positive. For the sake of this problem, don't simplify the fraction. I know 3 over 9 simplifies down to 1/3, but just make it positive. Make it positive 3 over 9. Because they also have to have the same distance, right? So the A and the B of the right triangle that you make with each side has to be the same. So my A is 3, my B is 9. So when I make my other side, I'm going to use those same distances. I'm going to use those same exact numbers, 3 and 9. Okay? So we figured out that our slope is positive 3 over 9. So we go up 3, right 9. So I'm going to start at C and go up 3, and then right 1, 2, 3, 4, 5, 6, 7, 8, 9. And that should be where D lands. And then let's connect D to A. You can check your work because CB is supposed to have the same slope as DA. So just double check that. Let's find the slope of BC. What's its rise? We went up how far? We went up 4. How far over did we go? And that equals 2. We went up and right, so it will be positive slope. What's the slope of DA? How far down did we go? Oh, I miscounted. Sorry. This is 5, right? Does 5 over 2 simplify? 1, 2, 3, 4, 5. Discounted there. That should be 5 over 2. And we went down 5, and then we went which way? Left 2. Negative over negative simplifies down to a positive. So did we find D in the right spot? Yes. Opposite sides are parallel. We're good. That's one way of checking. You just find the slope of an opposite side, and then use that to find the slope of the missing side. So D would be located at, what are the coordinates of D? Where is it, 9, 6? All right. Very quietly. Questions over that? Okay, that on the front we dealt with more of what parallelograms look like in the coordinate plane. If you flip it over to the back, we're going to take a look at what they look like, not in the coordinate plane. Okay. It says in parallelogram ABCD diagonals AC and BD intersect at point L. If AL equals x minus 2 and CL equals 3x minus 16, then what's the length of the diagonal AC? What are we missing here? That would be really helpful. What are we missing? What do they not give us? What are we missing? That we usually get. But you might have in other problems on the same sheet. What is it? No, we don't need coordinates for this one. How can we, what do we need to do to get a good visual to help us start solving this problem? No. No. We don't have to use the coordinate plane. What do you have in example 4 that you don't have in example 3? Yeah, we don't have a picture, right? There's no picture. They just gave us all this information, but we don't know what the parallelogram looks like. So what do you think we need to do? Draw it. To draw a parallelogram, this is how I draw it. Okay? I make a side. And I make another side slightly off from that one, like so. And then I just connect. Yep. It's not, doesn't need to be perfect. I'm not looking for Mona Lisa here. You can tell mine is not perfect. But just a rough sketch of what that parallelogram will look like. That's how I like to draw it. Okay? And then label. It's really important when you label. Go in order. It doesn't matter which vertex you start with. I'm going to start with that one. But it has to go in order of how the letters are written. And it doesn't matter what order you go. So I'm going to go A. The next one is going to be B, C, and then D. You also could have done A and then went down to B, C, and D. They have to go in order. You can't jump around. Okay. Have to go in order. So they gave us info about the diagonals. They said that what is it? We have diagonal AC, and we have diagonal BD, and they intersect at this point L. Okay. They said AL is x minus 2, and they said CL is 3x minus 16. And we want to find the length of diagonal AC. But what do we need to find in order to find the length? The value of what? We find x. Good. How can we find x? Think about what they gave us. They gave us info on diagonals. They also told us we had a parallelogram. So ask yourself, well, what do I know about the diagonals of a parallelogram? Yeah, why can we do that? Why do they equal the same thing? Why? What do they do to each other? They intersect, but when they intersect, what are they doing? We're talking about on the front. They cut each other in half, which is what? They bisect. Yeah. Our diagonals bisect each other. So Leah is right. They are congruent because they bisect each other. They're cutting each other in half. So the two parts of the diagonal are going to be the same, which makes them congruent. And as Leah said, we can set them equal to each other. Little helpful hint in geometry. If you're given this problem and you're like, I have no idea what I'm supposed to be doing right now. Were we given segments or angles? Segments. Really, the only thing you can do with them is set them equal. So if you're given segments and you're like, I don't know what to do, set them equal to each other, you're probably right. Okay? Like 99% of the time, that's what you're doing with segments. Okay? So set them equal. Probably correct. And then solve this equation. How are we going to solve the equation? What do we need to do first? Yeah, which x do we want to move? I like moving the little one. Which one's the little one? Yeah, just subtract x. If it's helpful, put the 1 in front. What is 3x minus 1x? 2x. And then move the 16 over. Negative 2 plus 16. And then what do we have to do with the 2? Divide by 2. And x equals what? Are we done? I found x. It should be done, right? What do we have left to do? Yeah, plug it in. We need to find AC. Which one do we want to plug it into? X minus 2. But it doesn't matter which one you plug it into. No. If we plug 7 into x, this is just less work. That's why I like x minus 2. Less math I have to do. Easier math, too. What is 7 minus 2? 5. But that gave me the length of AL. AL is 5. But that means automatically CL is also what? 5. Which means the length of the entire diagonal is what? So if you do 5 plus 5, that gives us 10. The entire diagonal is 10. Watch this over. You have to remember when you're given a parallelogram, you're given diagonals, you have to remember, oh, diagonals bisect each other. And the next example, each quadrilateral below is a parallelogram. So we know these are parallelograms. We're going to find the value of the missing variables. So we take a look at A. Which one do we want to find first? X or Y? It doesn't matter. X. X is what? Is X a side or an angle? It's a side. What do we know about sides in parallelograms? The parallel? Is that going to help us find X? No. Parallel has to do with slope or angles. What else do we know about the sides? Yeah, they're equal to each other. So GF is equal to what other side? 15, DE. Well, what can we do if we know that they're equal? Set them equal to each other. So we can do 4x minus 1 equals 15. And again, when you're dealing with sides, you're dealing with segments. If all else fails, set them equal to each other. Most of the time, that's what you're supposed to do anyways. And then solve, move the 1 over. You get 16, divide by 4, and x is equal to. How are we going to find y? We know we have a parallelogram. Is y a side or an angle? Angle. So start asking yourself, what do I know about the angles of a parallelogram? Specifically, what about these angles? Are they next to each other or across from each other? They're across, right? So that means they're opposite. What do we know about opposite angles in a parallelogram? Opposite. I'll get to that one in a second. They're equal. So here's y. What angle is opposite of y? 53. So that means y has to equal what? There you go. That's the hard part about this unit. When you're not coordinate plane, it's pretty much telling you how to solve it. You just have to remember what certain things mean. Here, when it's not in the coordinate plane, you have to remember those facts. Okay? And I had scaled a lot of those facts. There's a lot more facts about parallelograms, but I just narrowed it down to the important ones. Help you out. Okay? So you have to remember diagonals bisect each other. You have to remember that opposite angles are congruent. You have to remember that opposite sides are congruent. You have to remember opposite sides are parallel. So 4 really important things you have to remember about parallelograms. If we take a look at B, we know we have a parallelogram. Are these angles across from each other? No. So are they equal to each other? No. Okay. But we know we have a parallelogram. So what do we know about the opposite sides of a parallelogram? We'll get to that. You're like 2 steps ahead of me, but you both are correct. I like your thinking. What do we know about the opposite sides of a parallelogram? Well, the opposite sides are the same. They're also what? It's a parallelogram. Opposite sides are. It's a parallelogram. Opposite sides are parallel. Okay. So I know you 3 boys really need to calm down. It's super distracting. Like I'm distracted by what you're doing right now. Okay. So I know these sides are. The smartboard wants to work. Come on, smartboard. No, just sometimes you There we go. If I extend these sides, right? If I extend them, they're parallel to each other. The other side, like this side right here, is acting as a transversal. We talked about this with trapezoids. We extend those sides to make parallel lines cut by a transversal. Lee and Isaac, you were saying this. What kind of angles are x plus 10 and 2x plus 20? They're same side interior. What do we know about same side interior angles? They equal to 180. So when you have angles, when you have parallelograms, when you have trapezoids, when you have angles that are on top of one another, they're always going to add to 180 degrees because they're same side interior angles. So angles across from each other are equal. Angles on top of one another add to 180. And then so, what do we have to do in order to solve? Combine our like terms. We combine our like terms, what do we get? 30. And then when we get x by itself, what do we have to do with the 30? 30. Divide by 3, so x ends up equaling what? Example 5, it should have said it is a parallelogram. It doesn't say that, and it should. So just put that in there. It's a parallelogram. So if we know that this quadrilateral is a parallelogram, we want to find the value of that missing angle, VXW. Well, think about what you know about parallelograms. What do we know about their opposite sides? They're equal to each other, but are we trying to find a side? No. We're trying to find an angle. So what else do we know about parallelograms and their sides? It's a parallelogram, the opposite sides are parallel. So the fact that we know that their opposite sides are parallel is going to help us find missing angles. Parallel lines help us find missing angles. So I know YV and XW are parallel to each other. And again, if it's helpful, I don't know why it doesn't like the highlighter button today. There we go. If we extend these sides, here's this side, here's this side. This middle side is acting as a transversal, and that's going to help us. What shape, if we kind of cut this figure in half, what shape is that missing triangle or angle in? Kind of give you the answer. Right? This angle, come on, fretboard. Why are you being difficult today? There you go. That missing angle is inside that triangle. And what do we know about all the angles of a triangle? They equal 180. Well, if we can figure out what that top angle is, we can easily find out what our missing angle is. Okay? So I'm going to use this angle 52 right here to help me find that top angle. What kind of angles are this orange angle and this top angle? They're alternate interior angles. Very good. What do we know about alternate interior angles? They're congruent. So they are both going to be 52. Now that we know what that top angle is, what can we do with 52 and 60 to figure out our missing angle? What did we just say? What do we know about all the angles of a triangle? So we just subtract them from 180. And what do we get? We do 180 minus 62 minus 60. So our missing angle is 68 degrees. I'll write that a little bit better. And done. questions over that? No? Okay. That's all we're going to do today.